with the power rule. And also a couple of our other rules, okay? Because up until now, we've been having to do limits, and I didn't even make y'all do that many, because they're not fun. And they get really messy really quickly, especially if you start getting things that are to like third and fourth powers. Fractions are ugly, square roots make it difficult, right? We don't like to do limit definition of derivatives all that much. So what we want is we want these other types of rules that allow us to calculate the derivatives quickly. So can anyone tell me the relationship that we've noticed between our functions and their derivatives? Or has anyone noticed a relationship? No? Okay, that's okay. Let's pull up and see if we can see a relationship. So here I have my original graph is x squared. Then I have the derivative of f is in blue. What does it look like the degree of my blue graph is? 1. Okay, so if the degree of my red graph was 2, my blue graph is 1. What is the relationship between those? It is 1 degree less. Yes? Okay, if my original graph is now a cubic, what does it look like the degree of my derivative graph is? 2. If my original graph degree is 4, what does it look like the degree of my derivative graph is now? So what does it look like our pattern is? -1 in the yes, well, what am I subtracting 1 from? The power or the degree. Yeah, the exponent. Yes, which is why it's called the power rule, right? So our derivative, so dx of cx, so we have 2 that are right here, and the derivative of dx of ax to the n. So let's think about this first one. If it's going to be 1 degree less, yes, and I just have an x there, well, what's 1 less than 1? 0. And anything to the 0 power is 1. So then I'm just going to have whatever that constant is. So the derivative of just an x is always just going to be c. Very straightforward. Now, when we start throwing things that have bigger powers,
do we write this inside the tabs?
yes, so you're going to open it up, put that on the inside. Now, the second one, we did say that we are going to subtract 1 from our exponent. Now, from just the graphs that we graphed, it's a little bit hard to see, but what we also actually do is we multiply the front by our original derivative. So we bring down our original and multiply that by whatever constant we have on the front, and then we subtract 1 from our exponent. Our lives a little bit easier. So find the derivative of the following. So I have f of x equals 5x to the third. So how do I denote my derivative? There we go. Okay, so again, I have a 5. The 5 is just going to stay like by itself out to the front. I'm going to bring down my original exponent. Yes. Then I have my x, and then I'm going to subtract 1 from my exponent. So 5 times 3 gives us
15.
And the 3 minus 1 gives us 2. So our derivative would be 15x squared. Yay, we're done. That's it. That is a lot easier, right? So we are very thankful for the mathematician that took the time to come up with that general rule for us, so we don't have to do the limit process every single time. Probably Newton, but I can't. Newton and Leibniz were the 2 main mathematicians that we credit for most of calculus, but there were a few here and there that also contributed. Alright, next up we have a constant. We didn't technically put a rule on a constant. So what's my degree of a constant? Nope, that would be if I had an x. No degree or a degree of? 0. Yeah, okay. So can I subtract if I don't have an x? No. Okay. So we might need to think through this one a little bit. What does that graph look like?
It looks like
Horizontal line at 12. Alright. Remind me, what is the derivative? A derivative is the slope of the tangent line. Alright, and what is the slope of that entire line? 0. So my f prime of x is going to be 0. And that's the case for any constant. The derivative of a constant is just 0. Then the last one is to the first power. What are we going to get for our derivative here? Just 5. That's our answer. Yay. Questions on those? Continuing on. Alright, can I use my power rule in this one? Does it look like our stuff's been looking like? Does it look like it's in the right form? No, not on that first one, no. Well, since we don't know any other rules right now, okay, it would hopefully be helpful for us to still be able to use the one rule that we know, yes? Cool. So on the bottom right, there's a spot that says reminders. I would write this down on our reminder. Something that we need to remind ourselves of is if I have 1 over x to the b power, I can also write that as x to the negative b. So how could I rewrite y on this first one? Yeah, so now does that look like something that we could apply our power rule to? Yeah. Now we have a negative exponent this time, so we do have to be a little bit careful. So this time I have a y prime, because it's not f of x this time. But I'm still going to do the same process. I'm going to bring down my exponent, and then I'm still going to subtract 1. So 3 times the negative 2 gives us negative 6. And I get x to the negative 3. Now, for your response question, I'm leaving my answer like that. Okay? If this was a multiple choice question, they are going to probably rewrite it as a fraction since it was given as a fraction. So you might have to convert back there at the end. Yes, no, maybe. Yeah.
For your response, would you have to go all the way out, or
No.
just leave it?
You could have left it like this. Yeah.
Okay.
Now I will say most of the time, a free response question is not just going to ask you to take the derivative. You would have to take the derivative and then do other things. So it's going to be beneficial for you to at least simplify somewhat, because then you're going to be plugging stuff into it or doing other stuff. So like you're going to end up needing to simplify anyway. But other questions? Alright, so our next one we have a fraction again, but what else do we have? It's not a square root, it's a cubed root. Oh, okay. So that also doesn't fit my power rule. Is there a reminder that we might need reminding of?
Probably.
Yeah.
That might help us rewrite that. So I can use my power rule.
Probably.
There is. So if I have, what did I use over there? B. Okay. If I have the a root of x to the b power, we can rewrite that as x to the
A over B.
b over a. So your index is your denominator. So you might write yourself a little note of that. Which is helpful, because now this can become 5/3. Are we okay that 5/3 is just a constant? So I can write it in the front. Okay. And then this is going to become x to the what? It's on the bottom, so it's going to need to be
1 over 3.
nope, that's not the bottom part. It's on the bottom, so that means it's going to be negative. Okay. Then our b value is 1 and our a value is 3. So I do get a negative 1/3. Now is it in a form that we could use our power rule? Yeah. So dy dx. Remember that's our other format for our derivative. So I have 5/3 times negative 1/3 times x to the negative 1/3 minus 1. Now, am I always going to write out these steps like this every single time? No. Usually I'm just going to multiply and subtract. But especially here at the beginning, it doesn't hurt to go ahead and look at it. So 5 times 1 gives us 5. 3 times 3 gives us 9. Okay. And what is negative 1/3 minus 1?
Negative 4.
Yeah, usually if we're going to write it as an exponent, we're going to write it as an improper fraction. So yeah, so we would subtract 3/3, right? So negative 1/3 minus 3/3 gives us negative 4. Or, if we were to rewrite that, we would have negative 5 over 9 times the 3rd root of x to the 4th. Again, that's more helpful if it's like a multiple choice question. What other questions? That.
I can see it.
Are we ready for a couple more rules? We do have a couple of functions that would be a little hard to put in using our limit notation. So we actually have special rules for those. Again, that somebody took the time to figure out, and now we just get to use their hard work. So these are called our transcendental functions. Does anybody know what transcendental means? No clue? Okay. So to transcend, it means to like go above, right? You're transcending something. And it can also kind of mean to like go back and forth. So with our things that are written as like polynomials, like or like where I just have a just like a normal exponent, right? Like I can always just subtract 1 and like that's all we can do. Our transcendental functions are going to be the ones that are over there on the bottom half of the left and right side. So those are all of your trig functions, your e to the x function, and your natural log function. Okay, those are all of our transcendental functions. Meaning that they all have kind of their own special rules. We're going to focus on the first 3 trig functions and then our natural log and our exponential. So the derivative of sine of x is actually cosine of x. The derivative of cosine of x is negative sine of x. The derivative of tangent of x is secant squared of x. So those are on the left side. On the right side, we have the derivative of, they write the natural log of u, so I'll do that way too, is going to be 1 over u. And the derivative of our exponential. So up until now, like pi, right? We get pi from relating the circumference to the radius of a circle. Yes? Hopefully we have all heard that before. That's where we get the number pi from. It's basically relating a circular shape to a straight shape, which is not a nice, pretty exact number, and that's where we get pi from. E is actually a special number because the rate of change of e to the x is itself. So what is rate of change? Slope. So if the slope of e to the x is itself, what does that mean? What's another thing that we've been talking about is the slope of something. The derivative. So if the derivative, or the rate of change of e to the x is itself, that means that the derivative of e to the x is e to the x. I think it also puts it as e to the u, so you can have a u on there as well. The variable doesn't matter. Yes, no, maybe so. Now, you will also notice on here, the third and fourth down on the left are your multiplication and your division rules, which is what we're going to look at on Thursday. And that's because when we are multiplying and dividing, we have special rules, okay? These aren't on here, but just so you know that if I am taking the derivative of f of x plus or minus g of x. Now, remember that we're not using the limit process, but these are still represented by limits, right? So because of how our limits work, we can actually just go ahead and take the derivative of these two things separately. Now, that does not work for multiplication and division, which is why they get their own rules. And again, we'll look at those on Thursday. But for everything else, we can just add and subtract derivatives. So that part's easy. So that might be something you want to put on the reminders, or even on the backside if you wanted to put that down somewhere. Okay, so let's look at an example. So here we're just adding and subtracting, yes, like I said. So let's use our just derivative rule. If I bring down my 4, what do I get? 3 times 4 gives us 12. If I subtract 1, what do I get? Are we all okay with that? Yes?
Yes.
If it helps you to write out the multiplication and subtraction, you can. I will say we don't want to do that for super long because that's a lot of writing for one question. So we want to get to a point where we can, again, bring down our 3. 2 times 3 gives us 6. 3 minus 1 gives us x squared. Now, it probably would be helpful for us to rewrite this last one. Remember, I can rewrite that as an x to the negative second. So this time we're bringing down our negative 2. So negative 2 minus 1 gives us negative 3. Because I'm subtracting 1. So negative 2 minus 1 is a negative 3. So just be careful with your negatives. It's a common mistake. What questions do you have? Okay. Let's look at one using our other rules that we learned. I have an e to the x and a cosine. So it says write the equation of the tangent line at x equals 0. What are the two things I need to write the equation of a line? Point and a slope. Well, what is going to be our slope of the tangent line? What's the slope of the tangent line? The derivative, right? So we're going to take our derivative to find this. Do I have a point already? Kind of. Do we have an x value? Yeah. Are we all okay with that? Okay. But how do I find the y value? Cool. So e to the 0 is going to give us 1. So I get 3/4. Cosine of 0 is, so I get 2. So this would be 8/4 plus 3/4 gives us 11/4. Yes?
Yeah.
Now, find my slope. We said that we have to do what? Take the derivative. Lucky for us, we should know these now, or at least we have them written down. Good. So we said that the derivative of e to the x is what? E to the x. Yes? So that's just going to be e to the x. Again, we can also just add or subtract our derivative. So what did we say the derivative of cosine is? Negative sine. So that would be the derivative, right? And remember, that's just our equation, okay? But if I want to find the slope of the tangent line at x equals 0, what do we need to do?
Plug in 0.
Plug in 0, right? This is the equation that allows us to find the slope at any x value. So if I want to find the actual slope at a particular x value, I just plug that in. So again, e to the 0 is just 1. What is sine of 0?
1. No. Wait, 0.
0. Yeah. So we just get 3/4. So we would have y minus 11/4 equals 3/4 times x minus 0. So just 3/4 x. Yes, no, maybe. What questions do we have there? So this would be our final answer. So let's look at two last kinds. Again, these ones are kind of deceptive. So like right now, what do I have right here in between my top and my bottom? What operation do we have going on? Division, right? And we said we don't have a way to do division yet. So what could I do in order to not have to do division?
The negative x at the top.
We could, but then I would still have multiplication, and I don't have a multiplication rule yet either. So how many things do I have on bottom?
1.
Just one, right? So are we okay? That is the same thing as this?
Sure.
As long as I have one thing on bottom, right? The second I have like x minus 1 or x plus 1, then all of a sudden I can't just do the division, and we do have to have that division rule that we're going to learn later on. But for right now, we can. So let's see. What is the derivative of 4x Where?
8x.
To the first, but yes. What's the derivative of 2?
0.
What side's Carter? What's the derivative of 5x to the negative first?
-5 to the negative second.
Not negative 5 to the negative second, but negative 5
X.
x to the negative second. Yes. Alright, and then on this last one, we have multiplication. We do not have a multiplication rule yet. So what might I want to do?
Distribute.
Cool. So same thing, I haven't taken my derivative yet, just like with our limit. I can't drop my derivative symbol yet. But I have 2x to the 4th minus 5x to the 3rd. So now I can take the derivative of that. What's the derivative of 2x to the 4th? Minus?
Wait, just 30.
Yeah, nothing. Much faster process, right, than our limit process. It's like we like these much, much more.